Hello everyone, welcome back to Higher Mathematics, and in this video we are going to solve this really interesting exponential equation x cubed equal to 6 to the power x. And a lot of students can easily say, okay, I can easily solve it, it looks like an easy equation, we have like not a huge power, we have 3, we have 6 right here, but if we look closely to that equation, this is not like an easy equation, because we have x as our base and x as our power. We cannot like solve it by inspection, or we cannot solve it like in 30 or 1 minute, in 30 seconds or 1 minute. So we need to know, or we need to learn about really interesting approach, and I'm going to solve this approach. I'm going to show you this approach here in just 1 or 2 minutes. First of all, we have power right here, we have 3, we have x right here, so it's really good to know about natural log, for example, because if we take natural log of x cubed on the left hand side, and we need to do this on the right hand side, so natural log 6 to the power x. So what we did, we just take natural log on both sides, right here and right here. And why I do that? Because if you know a little bit about natural log, this power goes right here and this x goes right here. So it helps us a lot, because we don't have like these powers and exponents in a power section. Okay, so we have like 3 times natural log x equal to x times natural log 6. Yeah, so really great, because right now we don't have power, so which is really good. Right now, how can we solve all kind of equations? We need to group x exponent that we need to find on the left hand side, and our constant on the right hand side. So let's do like that right here. So let's divide both sides, for example, by x. Yeah, if we divide both sides by x, from here we can easily cancel this x, and it appears right here in the numerator. So we have like 3 times natural log x over x equal to, from here we cancelled it, so we have only natural log 6. Yeah, so this is really important step right here. Okay, what is the second step? Right here we still have this 3, this is a constant. We need to bring this right here to the right hand side, so we need to divide it by 3 both sides. So we have like natural log x over x equal to natural log 6 over 3. Okay, so right now we have this really interesting equation, but it's not like an easy equation, because we have our x right here in an argument of this natural log, and we have x in our denominator, so it's kind of complicated question right now. So we need to know, or we need to learn about Lambert W function. I know a lot of students have difficulties with this Lambert W function, so I want to explain it, use this function in simple words right here. For example, imagine that you have expression like that. If you have a times e to the power a, imagine that you have expression like that, where a is whatever expression you want, like doesn't matter, complicated, very easy expression. So just imagine this expression, and we have e, and here is a question: if we have natural Lambert W function from this expression, this is equal only to our a, which is really great. So a lot of students have difficulties with this Lambert W function, but if you have this expression, a right here, we have e. If we take Lambert W function, we have only our a, which is the same as right here, so power of this e. Okay, which is really great. So right now let's try to create something like that right here in natural log x equal to natural log 6 over 3. Let's try to create it. I just rewrite Lambert W function right here. So the Lambert W function of a times e to the power a equal to a. Okay, let's try to create something like that right here. So first of all, we need to create e. How can we do this? Right here we have x in our denominator, so let's write this x as e to the power natural log x. So we have the same natural log x. And in our denominator, let's write this x as e to the power natural log x, okay, equal to natural log 6 over 3. Okay, so right now we have something like that. So, and one really important moment, we have e in our denominator, so let's try to bring this expression right here to our numerator. And as you know, if you bring this from our denominator to numerator, we need to put minus right here. So as a result, we have like that. We have e times minus natural log x times natural log x equal to natural log 6 over 3. Yeah, so we just bring this expression to our numerator. Yeah, so right now let's try to swap these positions right here, because we have e in the second position and we have this expression in the first position. Yeah, so let's try to express this like that. Let's change position. We have natural log x times e to the power minus natural log x equal to natural log 6 over 3. Okay, but for Lambert W function, we need to have like at the same a. Right here we have minus natural log x, we have e, which is really great, but this natural log x, we need to have the same as right here. So we need to multiply both sides by -1. And if you multiply it, we will have like a really interesting expression. We have like minus natural log x times e to the power minus natural log x equal to minus natural log 6 over 3. And look closely to this expression. So we have a times e to the power a in Lambert W function rule. So if we look like that right here, we have the same expression, this one, the same this one, so which is our a, and the same e we have, yeah? So we can easily apply Lambert W function without any problems. So if we apply Lambert W function, of course, from both sides, from left and from right, so from here we have only our a, but a in our case equal to minus natural log x, so minus natural log x equal to Lambert W function of this expression minus natural log 6 over 3. Okay, which is really great right now. So this is a constant on the right hand side, and we need to find our x. How can we do this? Let's write this minus natural log x as e to the power natural log x to the power -1. We can easily write it, this is absolutely the same, equal to Lambert W function of minus natural log 6 over 3. Yeah, so we can write it something like that. And of course, if we take e right here, we need to write it right here. So this is e to the power Lambert W function. So we just take this, we just write base of e on both sides. Yeah, and right here we bring this minus as power of -1. Okay, right now what we're going to do next? This can easily be cancelled right here because this is 1, and we have like x to the power -1. X to the power -1 equal to e to the power Lambert W function of minus natural log 6 over 3. But one really interesting moment, this is x to the power -1. If we wanted to find our x, we just need to bring this to our denominator. So we have x equal to 1 over e to the power Lambert W function of minus natural log 6 over 3. Okay, this is our answer, but I know that you're interested like in approximate solution or in integer solution. Let's try to find it. Before this video, I find this exactly the value of this x right here, and I try to find approximation for you, approximately answer. But one really interesting moment. This Lambert W function at this point does not exist. So Lambert W function in the point of minus natural log 6 over 3, if you plug in like a calculator, any math calculator, this expression does not exist. So right here, no real roots, because right here Lambert W function of minus natural log 6 does not exist. Then all expression does not exist because we will have like complex roots, I guess, yeah? And if we write it in a graph form right here, so if we draw a graph, so in the beginning we have this expression, we have x cube equal to 6 to the x. So if we know that we have no roots right here, we can easily write a real quick graph, so we can easily see that we don't have any solution. So x cube, this is our function like that. So for example, like that, we can write it in 0 and right here, and we have x 6 to the x. This is exponential function, but we know that we don't have real roots. So it's approximately looks like that, maybe in this point. So right here, as you can see, this goes to infinity and this goes to infinity, but we don't have any point of intersection. Yeah. So these lines does not intersect. So we can easily write right here, no point of intersection yeah, right here, no point of intersection, and of course no real roots but complex roots. Really interesting question. Let's spend 1 minute to go it step by step real quick. So here's our question. First step, natural log, because we have our power, so we just need to bring this to our as a constant right here, so natural log on both sides, our first step. Then we need to group our x's on the left hand side and our constant on the right hand side. This is our second step. Third step, we need to know about Lambert W function. A lot of students have difficulties with this Lambert W function, but saying in simple words, we have expression like that, a times e to the power a, where a is wherever you want expression, doesn't matter, complicated, not complicated. If you have something like that, if you take the Lambert W function, you have only our a, where a is our this one or this one, absolutely the same. Then steps for simplifying this expression, taking e on both sides, so like 10th grade or 11th grade math right here, so nothing hard. And as a result, I we have like no real roots because this is like complex number. So in this point, Lambert W function does not exist. And of course, our graph. Really interesting question. So if you still have any question, write your question in the comment. I try to help everyone. And thank you for watching. Thank you for your support. See you in the next videos. Have a great day.